Well, it's great to be here. I have a long history with Cloud Foundry, so I'm really thrilled for this. And I know these talks are kind of short. So what I'm going to be talking about is boosting the performance of your Spring applications using Buildpacks on Cloud Foundry. And there's a lot of reasons for which it's good to improve the performance of our applications. The opportunities for improvement range from startup time, warm-up time of our applications, which helps us achieve things like scaling down to very few instances or zero, improving the throughput and the latency, just the user experience, and reducing the memory footprint so that we can save money, essentially, in infrastructure. So we're really motivated to do this. And what I want to cover today is what are those performance opportunities specifically for Spring Boot applications, how Java introduces opportunities and how Spring Boot makes it easy and leverages them for us. If you wanted to approach this in a DIY fashion with the OSS Buildpacks, I kind of went down that rabbit hole. So I'll tell you a little bit of what I learned and then what Tanzu would bring to the table to make this possible. So let's go into Java. So here's just sort of a summary table. You don't have to read it all. We're going to go into some of these things. But in general, on the left, you see the opportunities between Java and Spring to help you improve the performance of your applications. And you see the version of Spring Boot where these changes were introduced to the Spring community. A little bit of the impact. I'm not really specifying if it's startup or warm-up, but you kind of see how impactful they are. Again, we'll go into these a little bit more. So the color coding here is native images in Crack have certain drawbacks. So the real focus from the Spring team and also from the Tanzu Java Buildpacks team is to focus on the ones that are in green. And then the one that is blue, Java 25 will be the next long-term release for Java. So we're kind of looking forward to future improvements in that version. So ahead of time processing means that you're doing some pre-calculations during compilation to take away some of the dynamic behavior at runtime because that's a bit slower, and to generate static code and include that in your application that gets built into your jar file. This is a requirement if you're going to compile your application into a native executable, but it's also compatible if you're just using a JVM. So we can still leverage that. And this was introduced in Spring Boot 3.0. Again, native images in Crack, I mentioned there's a few drawbacks, but a native image, essentially you're compiling something in a way that won't need a JVM. You just start it as, like an exe on your computer, right? Directly on the operating system. It's very static, and because you have to pre-calculate all of the things that would be dynamic at runtime, it's easy for some applications, but it's also not so easy for other applications. A lot of Spring is very dynamic, all auto configuration. And so sometimes it's not realistic for enterprises to necessarily achieve this with existing applications. So we're really trying to find a way forward that has less limitations. Coordinated restore at checkpoint Crack is very, very effective. These two strategies are very effective. But the problem with restore at checkpoint is what you do is you start up an application. You can even run some traffic through it to get a warmed up state of your JVM, and then you take a snapshot of the memory. But in doing that, you might have already connected to databases, or you might have already processed private information, and so there's a danger that you capture that in your memory snapshot. So you have to be very careful about how you do that. So again, kind of some risks involved. So trying to find different ways forward with less risk. Another opportunity for improvement, this one has more to do with actual runtime, not startup, but introducing virtual threads. So this was introduced in Java 21, it was made GA, and Spring Boot 3.2 incorporated it through a simple property in your application properties file. But here we see before virtual threads. So if you think about your operating system and your computer and how many things it can do at a time, like my computer has 10 cores, but it can do many more than 10 things. And that's because at the operating system level, there is a scheduler that's managing your the kernel threads in relation to the physical threads, and it sort of time shares. So if a thread is not doing anything, if it's waiting for something, it doesn't occupy a physical thread. But inside the JVM, there was no such function, and so the platform threads, the regular threads you start in Java applications, were just sort of wrappers around these kernel threads, and when a Java operation was blocking, it stayed blocking, and it blocked that thread in the JVM, and then you had to scale horizontally. So what was introduced is a scheduler inside the JVM, so it can mimic that behavior that the operating system does so well. And a new type of very, very lightweight thread was introduced. That's where your Java operations are happening. So if those threads block, it doesn't really matter because they're so light, they're so fast. The JVM can start millions of these, and they don't block the platform threads. So you just need a small pool of platform threads, and the JVM will be able to process your load much more efficiently. So it's kind of like unlimited concurrency. That's the experience that essentially you have. No more block. You don't have to worry about writing blocking code because your blocking code doesn't actually block the platform threads. Another improvement that was introduced was not starting from that Uber jar that Spring Boot normally composes for you. It's very convenient to deal with just one big jar file that has all of your things and just say Java jar. But then as you start that, Spring Boot adds a jar launcher that has to look through the nested jars and pull them out. And if you're doing something at runtime and you need some static code, it also does that just in time. So it has a little performance hit. So now what's introduced is a way to extract that Uber jar into a small jar that only has your application class files and take all of those nested libraries out and then compose a proper class path and point to the main class of the application and not use that Spring Boot jar launcher at all. And that's a more efficient startup. So that's something that you can easily do, wherever you are. No drawbacks. And then there's something called class data sharing, which is another optimization where there is a training run where a cache is created that also is sort of a pre-calculation of what you'll need at runtime. And so then if you capture that cache, then you can use that cache during your startup command, and it'll also be faster. So those are the opportunities. And of course, looking forward in Java 25, there's more, but I just wanted to focus on what was possible now. So if you're on your computer, you can test all of these things in this way. Here are the commands. When you compile, you process those AOT calculations. You can also put that right into your POM file, so you can just do a regular package and have that done automatically. The second command is the one to extract into that optimized structure with the nested libraries taken out. Then do the training run, and if you've compiled with AOT, you want to make all conditions the same. So when you do the training run, you tell it you have compiled with AOT. And then at startup, again, you say, use the AOT files, also use the cache from the CDS run, and your startup will be faster. The virtual threads, it's better to do that in your application because it should really be a developer decision rather than sort of an operations decision about whether or not you want to use virtual threads for any given application. So, if we're doing this with OSS, how much of this can we realistically achieve, and where would we do it? So the anatomy of a build pack, if you look at the open source repo for the Java build pack, you'll see this is the structure. And most importantly, it has a library, a lib directory, and a config directory, which are the ones that have the different components that handle applications written in different languages. And so this is for the Java, that handle applications that have different characteristics, basically. And internally, there is sort of a modular component architecture to the Java build pack. And these components are a set of different things. So one is the component that actually processes your application. So our Spring Boot applications are going to be detected because they have a main class. So then the Java main Ruby component, as you see, that's highlighted, or it's in the middle, not between the highlights, Java main RB. That's the one that's going to be processing our Spring Boot applications because of the main class. A JRE will be selected. There's one by default, but if you change the version or if you change the vendor, a different JRE will be injected into our staging environment. And then depending on what you're doing, JDBC or different agents, different framework components can be included. So that's sort of the way that the build pack is structured. And then just in general, kind of stepping back, like how can you influence or how can you configure the way that the build pack behaves for different applications? So you have environment variables. So if you're an operator and want to make a change for the whole platform, you use a JBP_default_ whatever you're configuring. If you're a developer and you want to put it in your own manifest file, you can use JBP_config and then that same environment variable. So you would use this, for example, to change the version of Java. And then you can also get into the code if you want to get into the business of forking the build pack. Of course, that comes with responsibilities and consequences. So I see some reactions maybe of people who have tried it and gotten into trouble. But it's an open source repo, so you can fork it. And if you do fork it, then you have two choices, right? You can kind of go into the code that would process your Spring Boot applications anyway and just kind of modify that code, which is the simple approach. That's the simple way to do it. Or you can be more sophisticated and really understand this component architecture and then write components that function more like plugins. That is the way, of course, that the Tanzu Enterprise Java Build Pack does it. I explored the simple approach, and I'll tell you what I learned. So the simple approach is just to take this Java main RB file, because that's the one processing. You can see the detect method there that looks for main class. So this is the one that when you go to do your optimizations, you're dropped right into that compile method, right? Or that's the place to kind of go and understand what is there from your pushed application and how you can modify it. And then, so in the compile method, you would do whatever you can do. And then in the release method, you're basically composing what will be the startup command for your application. And so that does have to change. And so here's an example. If you look on the left, this is the default code. And you can see that your Uber jar will be started using an explicit class path and the main class, which in the case of a Spring Boot application is going to be your jar launcher. But if you're going to do all of these optimizations that I just talked about, you really want to start the application from this optimized extracted jar file. So you would have to get to the point of being able to do this in your modifications in the compile. So that's really as far as I'm going to go into the actual customization, because I want to more talk about sort of the lessons and the caveats that you should keep in mind. I hope I'm good on time. So here's a couple of things. So when the Java Build Pack, in your Java Build Pack staging environment, Cloud Foundry and the Java Build Pack actually enrich the application and its environment a bit, right? So first of all, it provides a JRE. It configures a cloud profile, and it adds certain jars to the class path. There's 3 jar files that are added for mutual TLS and for connections to any services you might be using. You have your VCAP environment variables, and those services are available for compilation. All of those things are provided during the compilation that happens on the platform. And the thing about AOT and CDS is that they're sensitive to all of these things, right? Even your user, the profile that you might be using in production for your application, the cloud profile, the order of the class path, of the jars in the class path. So you need, and when you have parity between your compile environment and your runtime environment, that's when these things are really going to be effective. So it is, so that's kind of like, that's something to keep in mind. So if you want to compile with, for AOT in the Java Build Pack, it's actually very difficult to make this work. I would say, unless you're going to write a product, kind of like the enterprise product that Tanzu has done, unless you're going to go that far with it, you're really not going to accomplish this. So I would kind of scratch this one off the DIY list. The tooling in order to do this is really not available in the OSS Java Build Pack. And there's a lot of subtleties in getting this configuration right. So I would say this is not really an opportunity to DIY. CDS is also very sensitive, but Cloud Foundry will help you with some of these sensitivities, right? So you need, of course, the same JRE. You need the same explicit and ordered class path with only jar files. But the extract command helps you prepare your application for CDS. It's best to have the same services, or you would need extra configuration. So, and if you're doing this in Cloud Foundry, then you will have all those same services. If you're doing it outside of Cloud Foundry, then you might have to configure your application to, for example, not try to do a database migration or whatever early database interactions it might do. You want to disable those because your CDS will fail. So running CDS on the platform is definitely better. Ideally, CDS and AOT go best together, but if you're going to DIY this, you would end up using CDS without AOT. And these are the libraries that I was talking about that Cloud Foundry adds to your application for mutual TLS, container to container, mutual TLS to container to the platform, and to load the environment variables and for Spring to be able to read those Java, CF, ENV, all. So if you are going to extract the jar file and do the CDS run, you're going to kind of lose these additions into your application. Again, the tooling is not really there to easily repackage them into your application. And so the workaround for this would be to take those 3 jar files and put them in your application POM file, and that would be the way to include them. So, and then the last thing is virtual threads is not something you really want to put into your build pack, because as I mentioned, this should be a developer decision. So leave it to the developers to put it in the application properties file, and that's because it's not appropriate for all applications. This is virtual threads are good for applications with I/O bound blocking operations, not necessarily long-running sort of CPU applications. And if a developer has created their own thread executor, then virtual threads, Spring Boot won't know that, and so it won't change that one. Until Java 24, there's a thread pinning issue to be aware of, so you'd want to test this before you use it in production. It's fixed after that. And so really, this is not something necessarily to DIY into that file. So that's kind of the caveats and the learning lessons that I got. It was a very fun rabbit hole to dive into. And actually, I should thank Anthony DeHaan and David O'Sullivan, and eventually also Stefan Nicole and Sebastian Deleuze were all really helpful with me going down all the rabbit holes and realizing that my ambitions maybe could not be quite as met as I was as hopeful for initially. So I want to step back and look at how VMware Tanzu is approaching this challenge, because they do actually solve all of these challenges. So the VMware Tanzu Java build pack builds on the OSS build pack, and they do properly add using that component architecture, and they compensate for all the tooling that is missing, and they support extracted jar files. Actually, they backported that to Spring Boot 2.7. It's introduced really in 3.3, but they backported it back to Spring Boot 2.7 to work for 2.7 applications, which also means that because extracted jar is a prerequisite for CDS, it also means that they can support CDS for one minor version back, so 3.2. There's support for Spring AOT, and so because all of this is also happening on the platform, then a lot of those considerations for having parity in the environment and knowing all of the things about the environment that you have to know in order for these things to be really effective, those are there, and they're taking advantage of all of that. So it works really beautifully. And then they really made it very easy to use. There's just one environment variable that you would set, and you could opt in separately to AOT and CDS. And generally, what this does is yield a 20% reduction in memory and a 2 times faster startup. Then the reference for that is that blog address that's right there. So that's really great. And then sort of stepping one step back from that, other advantages of using that VMware Tanzu Java build pack. So the JREs 8 and 11 actually have backported performance improvements that were introduced in Java 17. This comes from the Liberica Enterprise JRE. You also have extended JDK support for it. And then for the roadmap for Java 25, Java 25 will have the successor for CDS called JVM AOT Cache, so you would kind of get that automatically. You wouldn't have to rework your DIY solution. And one of those exciting things that is likely coming, I can't promise it, but it's likely coming when Java 25 is incorporated into the build pack, is that training run that you saw that is done also for CDS, when it's done for Java 25, it gives you an opportunity to actually capture sort of the warmed up, a warm-up run. And that warm-up run can come from a run in Cloud Foundry, and so that becomes the cache with which you start subsequently. So that profiling with those production runs, and then your startup it's not just your startup time that improves, but you're immediately at a warmed-up state. So that's super exciting, and I think September of this year, I think the code is ready to go. It's just a question of Java 25 becoming GA. Beyond that build pack, the build pack comes in a package. Tanzu platform or Tanzu Spring Essentials, and so that package has other benefits for Spring applications on Cloud Foundry, including if you have applications and you need to get them up to later versions of Spring so you can take advantage of more of these things. There's something called Spring Application Advisor that helps you upgrade your code and your library and your dependencies. It leverages these curated dependencies that we have in the enterprise Spring repository. Also, if you need to comply with regulatory rules and regulations and monitor that at runtime, there's some governance jar files that can be included in your application to help you do that. And then there's enterprise extensions for some of the Spring Cloud components through that as well, so really useful. So that's all the slideware I have. So let's see, hope we have time for this demo. I think I have a couple of minutes because we started late, so I'll try to make it through this quickly. So I'm just using Java version 21 here. And I've already pre-compiled sort of a baseline jar, just a regular Maven package command to get that baseline, target baseline app jar file. And then I used AOT to process a second jar file. So those are ready. And so in order to take that AOT compiled jar file and extract it into this optimized structure, this is a command that we run. And now that gives me that jar file. You can see that now this jar file is much smaller. Oops, sorry, this jar file is much smaller. And all of those libraries have been extracted into this lib directory. So I have my lib directory with all of my jars, only jars, and inside of the app.jar, my manifest has been updated with a proper class path, and the main class is now the main class of the Spring Boot application. So then we do a CDS training run. So we say on refresh, so we want the application to reach a certain point in the Spring lifecycle and exit, and at that point, capture the JSA cache into a file. And of course, we have to remember, since we compiled with AOT, we want that to be consistent, so we enable AOT now. And we're doing this with that optimized jar file, the smaller one. So this starts and exits by itself. And when it exits, we now have this CDS file. You can see app.jsa. So to compare the startup time. So here is the baseline startup time. This is on my computer. And so we see 4.122 seconds. And then this one is with the optimizations. And normally, this is 3.2. I don't know what's happening with my computer. This normally goes down to under 2 seconds. I don't know what's changed, but I want to show you, because as I said, it was a 50% improvement, right? This is something that's changed today. I don't know if I changed something. But I want to show you this on Cloud Foundry because you will really appreciate the 50% improvement there. So this is the baseline deployment. All I'm doing is setting Java 21 so that we're comparing apples to apples. And in the efficiency deployment, I've enabled just through one environment variable, so a lot easier, right? And it incorporates AOT as well. I've enabled both of them. And so I have those, I've pushed those already as well, just to save time. And so what I have deployed is these two applications. And so I'll show you. And so the startup, so this is running, thank you, Nick, so much. This is running in Nick's basement with 10-year-old hardware. So the application time is it's a slow startup, but it's the hardware. But it shows the difference very well. So here is the baseline. You can see that it defines the class path, and it uses the jar launcher as for the startup command. So here's this is what I'm talking about, right? And this is the optimized one, where it uses the jar file, the smaller jar file. And you can see here that it's also, here, it's enabling the JSA file that it composed on the platform. And I had also opted to use AOT. So it's included those two properties as well. And then if we look at the startup time on the platform, the baseline one took, where is it? 9 seconds here. And the optimized one took 4.6 seconds. So it halved it. So I think I'm out of time. So thank you. I had a virtual threads demo if I had time, but throughput is much faster with virtual threads for the right applications. And otherwise, thank you so much. Okay.